All right, good morning, and today we are making a collection of some different functions. We're going to call this our library of functions. Now, just like a library of books is just a collection of lots of different books, the library of functions will have 8 different functions. We're going to manipulate them throughout this year. Just kind of to start with, though, we're going to look at the simplest version, also known as like our parent function. So this original one, whenever we're graphing them, we are choosing what to plug in for x, and we will get some sort of f of x in return. Okay, so if I plug in 0 on this first one, we'll get 0. Plug in 1, I get 1, 2, I get 2, etc. Or I can go -1, I'll get -1. Okay, and if we think about it, so 0, 0, 1, 1, 2, 2, or -1, -1, -2, -2. So these values will run on this line. Okay, so we can either call this a line function and a linear function. Sometimes you might also see this called as the identity function. And right here for the shape, you can either write line or just draw a little picture of what it is. Okay, your next one. Once again, we are choosing values that will make this nice for ourselves. So we can put whatever we want in for f or for x. Now if I choose 10, 10 squared is 100. That's going to be hard to graph on here. So we choose smaller numbers. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Okay, we plot those. Now this is an example of something called a quadratic, or you might call it a square function. Many of you might know it's a parabola that we are going to get, which is symmetric. So back to the left, it'll be the same. If it's -1, it becomes 1. -2 is 4. -3 becomes 9. And there's our parabola. If at any point you need to pause for more time, feel free to do it. Our next one, x to the third, this is known as our cubic function. And for this, once again, put in whatever values we want, but we want it to be nice. So 0 squared or 0 cubed is 0, 1 cubed 1, 2 cubed is 8. Remember 2 times 2 times 2. -1 cubed, still -1. -2 cubed, -8. Now if you're confused on that, a negative cubed, negative times a negative is positive. We multiply it by another negative, and it's back negative. All right, and our shape, some of you might think of this as like a stretched S. Our last one here on this row is the absolute value function. And some of you might already know what this looks like. It looks like a V. If we plug in our values, oops, I put y there instead of f of x. If we plug in our values for x, if I plug in 0, the absolute value is 0, 0, 1 is 1, 2 is 2. Now if I plug in -1, I'm still going to get 1. -2, I'm going to get 2. Okay, so you draw like that. And we are done. All right, so we got 4 more functions to look at. On the back here, square root of x. So as we said, this is the square root. Once again, we want nice numbers. Give yourself a break. Okay, don't plug in values that are tough. Now we know if it's a square root, it has to be 0 or greater. You can't have a negative. So 0, square root of 0 is 0. Square root of 1 is 1. Square root of 2, it's going to be like 1.4 or something. That's not easy to graph, so don't do it. Square root of 4, square root of 9, those are easy to graph, 2 and 3. So that's what we're going to choose to do. All right, just kind of goes off to the right. This next one is known as a reciprocal function. And this one, you might recall with the denominator, we can't have x be 0. So we know, you don't have to put this necessarily, but we know that x will not exist at this dotted line here, this red dotted line. It won't exist as 0 because that would be undefined. So if we plug in a 1, 1 divided by 1 is 1. Plug in a 2, 1 divided by 2 is 1/2. A 3, 1 divided by 3 is 1/3. It's going to keep getting closer and closer to the x-axis. It will not touch it, though. It will just get closer and closer. Meanwhile, if I plug in a 1/2, 1 divided by 1/2 becomes 2. Up here, to get closer and closer to that y-axis, it's never going to touch. Now, that takes care of the positive version. What if I plug in a -1? I'm going to get -1. If I plug in a -2, I'll get -1/2. Okay, the same approach. It's going to get closer and closer to the x-axis, never going to touch. Closer and closer to the y-axis, never going to touch. So if we want, we could also put in that red dotted line on the x-axis. Okay, we're almost done. I'm moving fast. Just pause or rewatch if you need to. Okay, this next one is known as a cube root or cubic root. So once again, you're plugging in the values that are nice. So 0, cube root of 0 is 0, cube root of 1 is 1, cube root of 2, that's going to be nasty. Let's use our perfect cube. So cube root of 8 is 2. -1 is still -1, and -8 would be -2. Kind of looks like a squashed S, maybe. It's the hardest one to draw for me every time. Our last one, you'll notice the x is in the exponent. This is going to be an exponential function. Now, for this one, our 0, if we plug in a 0, anything raised to the 0 power is 1. So that's different. It's not a 0, 0 it's starting. If we plug in a 1, 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. Each time, you might notice it is doubling, which makes sense because that is our term right here is a 2. If it was a 3, it'd triple. If it was a 4, it'd quadruple. Now, if I go negative, -1, 2 to the -1, that's going to give us 1/2. Once again, it gets closer and closer. It's never going to touch the x-axis. Whoops, let me do that again. All right, today there's a Desmos activity. Go to It's Learning, sign into today's date. So go to Resources, Chapter 1, go to the date, so September 8th, and there will be instructions for how to sign in. If you need anything, let me know. Hope you guys have a great day, and I'll talk to you later.